Have you ever stood at a harbor and gazed up at a giant ship? These massive structures made of tons of steel seem too heavy to float. Yet there they are, bobbing gently on the water. How can something so heavy stay afloat? The answer lies in a fascinating scientific principle called buoyancy. Buoyancy is all around us. It's the force that makes objects float or sink in water, and it even affects how we feel in a swimming pool. Understanding buoyancy helps us design everything from ships to submarines to life jackets. The key to a ship's ability to float is its shape and the way it interacts with water. By pushing aside or displacing a large amount of water, a ship creates an upward force that counteracts its weight, allowing it to stay afloat. Let's dive deeper into the science behind this amazing phenomenon. Buoyancy is the upward force exerted by a fluid, like water, that opposes the weight of an immersed object. Imagine a rubber duck in a bathtub. When you push the duck down, the water pushes it back up. That upward push is buoyancy. This upward force occurs because the pressure of a fluid increases with depth. The deeper an object is submerged, the greater the pressure pushing up on its bottom surface compared to the pressure pushing down on its top surface. The difference in pressure creates the buoyant force. If the buoyant force acting on an object is equal to or greater than the object's weight, it will float. If the buoyant force is less than the object's weight, it will sink. Now, let's connect buoyancy to how ships float. A ship, despite its weight, floats because it displaces a volume of water equal to its own weight. Picture a ship entering the water. As it does, it pushes water out of the way, taking its place. The amount of water displaced by the ship has weight. And here's the crucial part. The buoyant force acting on the ship is equal to the weight of the water it displaces. This principle, known as Archimedes' principle, explains why a massive steel ship can float. The ship's hull is designed to displace a huge amount of water, enough water to have a weight equal to the weight of the ship itself. As long as the ship displaces enough water to equal its weight, it will stay afloat. Section 4, A History of Flotation, From Rafts to Liners. Humans have been harnessing the power of buoyancy for millennia. Early humans used simple rafts, made of logs or reeds tied together to float on water. These early boats relied on the buoyancy of the materials themselves. As shipbuilding advanced, people began to understand the relationship between a boat's shape, the water it displaced, and its ability to float. Hollowed-out logs evolved into canoes and dugouts. The invention of sails allowed people to harness the power of the wind to propel their boats. Over centuries, ship design and building techniques advanced. The use of iron and then steel for ship construction in the 19th century revolutionized the industry, allowing for larger and stronger vessels. Today, massive cargo ships, tankers, and cruise liners crisscross the globe, all thanks to our understanding of buoyancy and displacement. Section 5. Buoyancy in action, beyond boats. Buoyancy is not just about boats, it plays a role in many aspects of our lives. Swimmers, for instance, experience buoyancy. The human body, being less dense than water, naturally floats. Life jackets increase our buoyancy, making us float even more easily. Submarines use buoyancy to control their depth. By adjusting the amount of water in ballast tanks, a submarine can increase or decrease its overall density, allowing it to dive, surface, or remain at a specific depth. Even hot air balloons rely on buoyancy, but in this case it's the buoyancy of hot air in the atmosphere. Hot air is less dense than cold air, so a hot air balloon rises because it displaces a volume of cold air that weighs more than the balloon and the hot air inside it. Section 6. Understanding our buoyant world. Buoyancy is a fundamental principle of physics that explains why objects float or sink. From the simple act of a rubber duck floating in a bathtub to the awe-inspiring sight of a giant ship sailing across the ocean, buoyancy is at work all around us. Understanding buoyancy is essential for engineers who design ships, submarines, and other marine vessels. It's also important for anyone who enjoys water activities, from swimming to boating to fishing. By grasping the concepts of buoyancy and displacement, we gain a deeper appreciation for the world around us and the ingenuity of human inventions. So the next time you see a ship, a hot air balloon, or even a rubber duck, take a moment to marvel at the science that keeps them afloat.